Right, so this is a video going over the log review worksheet, logs and you review. I'm not going to go over it really slow. I'm going to go over it fairly quickly. And if you need extra help in specific pieces, you may want to rewatch the videos of those topics. So write in logarithmic form, that means there should be a log involved. So then this is the base, sorry, it went away. This is the base. It's called the base here, and it's called the base here. Remember, it's a subscript. It's a lower, it's like H2O. The value is V, and it's equal to the exponent. Remember, the logs are exponents. Evaluate this. All you really have to do is plug it in your calculator. Remember what you press. You press, well, you would do 1/2. And then you would hit alpha, window, and then the 5. And then allow you to put the 2 in, and then the 1/4. You should get -1 there for that problem. For this one, you want to solve to the nearest hundredth. So this is actually log base 10 of n is equal to 2.3. So we don't really know how to do that. So what we do is we change it to exponential. 10 to the 2.3 equals n. And we just put this in our calculator, and it's 199.53. What's the inverse? Remember, the first thing you want to do for inverse is you switch your x and your y. So x equals log base 3 of 2y minus 1. For finding the inverse of a log is exponential. So you do the log switch again. So 3 is the base, x is the exponent, equals 2y minus 1. Now you solve for y. So add 1. 3 to the x equals 2y. Divide by 2. I feel like this... Oh, where'd the 1 go? There we go. Divide by 2, and you get y equals 3 to the x plus 1 over 2 as the inverse. There's no f of x, but remember the notation would be f inverse of x. What is the asymptote of the function? So the asymptote revolves around that. So it's 2x minus 5. Wherever that's equal to 0, that's the asymptote. So 2x equals 5, divide by 2, and x equals 5 over 2. Asymptotes for logs are always x equals, and for exponentials it's y equals. This one's a weird problem, but it's one of those Common Core things that you have to get through. So they're telling you one of these is an expression that can estimate the value of a $270 Newfield phone in 1.2 years. So what this is saying is, according to a pricing website, Newfield phones lose 25% of their cash value over 1.2 years. That means every 1.2 years, 25% of their value is gone. Now, each one of these is an expression. This is not the expression I would have chosen, but this is an expression. So when we do this, it's going to be 270. That makes sense. Now, they all have e's. So when you do e's, remember the exponent is always rate times time. So the rate is 25%. So it's 0.25 is the rate. And the time is 1.2 years. Multiply these two together, and you get, so R times T is 0.3. So it's the 0.31, and because it's a decline, we know that, that E is 2.17 something. So that's bigger than 1. So this is not a decline function until we give this negative, and then that makes that a fraction, and it makes it a decline. So that's why whenever you're dealing with e's, compounded continuously and everything. When it's a decline, the negative is what shows us in the exponent. Now that doesn't work with compounded quarterly and things like that. Only works with continuously. Solve for x. So this has the x on it. I got to get that by itself. So it's b to the x equals a. Then I need to solve for that. In order to solve for an exponent, I need to use logs. So x log b equals log of a. Divide by log of b. So x equals log of a over log of b. Express n, log n, when n is that mess. So this is not the best problem here, but log of n, so we have this problem. So if I log both sides, I'm going to have what the log of n is. This is radical b squared. I mean, technically that's b, but let's get everything handled here. So this would be broken up, and what we're saying is log of n, we're multiplying these two things together, so it's log of a plus log of the square root of b squared. Now, hopefully you understand that the square root of b squared is just b. But what we want to make sure that you remember is that the square root of regular b is b to the 1/2 power. So just make sure you remember that part. But this is technically just log of b. Not the best problem, I guess. Okay, next page. So condense. So we want to mush these together. So that means when we condense, we have one log written at the end. So all these are going to come together with that. So this 1/3 goes on the z. Nothing else has an exponent. These two are added together. So their values are multiplied. This is minus z. So the z to the 1/3 goes on the bottom. So it's log base 5 of xy over the cubed root of z. Same deal here. Log base 5. These are just numbers. Just let them be. Let them be numbers and just let it happen. So this 1/2 comes to the top here. Remember that those are the exponents. And if it's positive, it goes on the top. Negative goes on the bottom. So this is positive 8. Log base 5 of 8, so the 8 goes on top. This is positive 5 here. And this is negative 6, so that goes negative 6 to the 1. I don't know why I just did I'm having a small bursts of crazy. So it's log base 5 of 8 times 5 over the square root of 6. You can also write, this is second over here, so writing log base 5 of 8 over radical 6 and multiply it times 5 on the side there, that's the same thing. Putting the 5 on the side is the same as putting the 5 on top. It's just the way you choose to write these problems. So for this particular problem, T is the number of months. So if I want to find, well, okay, let's go through the problem first. First, we're asking what's the purchase price of the car. It's $34,000. This number. The percent loss each month to the nearest 1/10 of a percent. So because this formula is in months and they're asking for each month, basically what I want to make sure that I have is I want 0.75 to the t power. So that means I have to get rid of that 12 on the bottom. So I bring it on the inside. When I do that, I get, we can do the 34,000 if you like to keep it there, but it's not part of this particular problem. So then I do it's 0.976311 to the t power, etc. And then so I'm going to do 1 minus this. And 1 minus that is 0.02368. Move it over 2 decimal places, and you get 2.4. So please remember 2.4% is the rate of decline every month. 97.6% is the amount that is retained. So the car retains 97.6% of its value, and it loses 2.4% of its value. It's good to know. And how much is the car worth after 1 year? So the best thing you can do about this, how much is the car worth after 1 year, is probably using the original formula is easier than using the formula you created here. It's the same thing and you get approximately the same answer. But if you round, weird things happen. So 1 year is 12 months. So this formula is in months. So I have to put 12 over 12, which is just 1. We do the math and we get 25500 to the nearest $100. So the next one is solve for p to the nearest tenth. There's a number of different ways to do this, but what I would recommend, and what is slightly easier than anything else, is make that a 4. Cross multiply, or just multiply by 4, and you get 4p equals 400. And then you solve. You're solving for an exponent, so you have to exponent. So you have to use logs. The p goes out in front. So p log of 4 equals log of 400. Divide by log of 4. And you get approximately to the nearest tenth, 4.3, I believe. When I did it myself, I did it a slightly different way, but the answer should be the same. I think that's it. So p is 4.3 to the nearest tenth. Okay, same deal with this one. 5 squared is 25. You can deal with the exponents like they're exponents, but you can make your life a lot easier if you just get rid of it. So 5 to the p equals 5.4. We're solving for an exponent, so you need to use your axe and make a log. And so p log 5 equals log of 5.4. Sorry, that's not there. Divide by log of 5. And p equals 1.0478. So the nearest tenth might not have been the best option for me, but it would be 1.0. So now we want to determine if the function represents growth or decay. So remember, growth or decay, we have to look at the annual percentage rate. So what we have to see is we have to bring that log of 2 divided by 0.5 into this. So where you have to actually do this math, put it in your calculator, and when you do that, this number right here, which is the one that would be in the parentheses, is 1.82587, etc. So since this number is greater than 0, greater than 1, it shows growth. Okay, so that's explain means use words. You can use math too. Obviously, I had to use math to figure out that number, but you have to use words too. So same deal for this one. When I put this part to the e power, I get 0.8238 to t power. So that's a t. So this number is less than 0. I keep doing that. It's less than 1. So it's a decay equation. Wow, that is really messy. All right, now we get to the word problems. So you have $10,000 you'd like to invest for 5 years. Bank A will give you an annual interest rate of 3.6, compounded quarterly. So the moment I see that, I know I have to remember my compounded quarterly formula. And then this one right here, an annual interest rate compounded continuously. Okay, so we have to think about, we have a bank A and we have a bank B, and we need to justify my answer. So justify means you're going to use words, but it's mostly math, and you have to have some math in there. That says math. Anyway, so compounded quarterly, you have to remember your quarterly formula. So the quarterly formula is, we're going to say bank A, T, is equal to P times 1 plus the rate divided by N. Now in this case, since we're dealing with quarterly, that's going to be the rate divided by 4 to the 4t power. We know everything except this number, so this makes this problem pretty easy. So we're going to put $10,000, 1 plus 0.036. Remember, this is the interest rate, but you have to write it as a decimal, so it's either 3.6 divided by 100, or you just move your decimal place over to get that 0.36. Oh, 4t, but t is 5 years. So it's 4 times 5, or 20. So plug that in. So A of 5 is 11,962 and 54 cents. It doesn't say where to round to, because you don't really need to. You're just trying to solve which bank will I make more money. And that's pretty obvious just looking at numbers. Okay, compounded continuously. You remember the compounded continuously? That's the one with the E. It's the PERT formula. So bank B, I guess I should call it bank B. So B of T is going to be your principal times your E to the rate times time. So if we want to do the principal, what are we doing this 5 years again? So this is 10,000 E to the rate. In this case, it's 3.4%, so it's 0.34 times 5 years. Plug that into your calculator, and after 5 years, you will have $11,853.05. So, I don't know about you, but I would choose bank A because you make more money, right? Which one will you make more money? Well, that one. So that's the math. Suppose you decide to go with bank A. How many years to the nearest year will it take to triple your money? So my money right now is 10,000. So to triple it, that's times 3. So when will I have made 30,000? So how many years? That's t. I'm solving for t, so I'm using exponents. So I need to use my formula, and I'm going to have to use logs to solve this. So this is my formula up here. Well, technically, I guess it's this one, but the 5 is a t. We don't know the amount of years. So it's 30,000 equals 10,000 times that decimal, which is 1.009 to the 4t. So all I did just then was I just put this part in my calculator and got that number for ease of writing, let's say. And now we're just going to solve. I'm going to switch a color here. So make sure you divide. You should get 3 here. Okay, log both sides. You're solving for an exponent, so that 4t should go out in front. I'm going to try to write neater now. Sorry, I try to move fast and I get really messy. All right, so I want to solve for this t right here. So I got to get rid of the log 1.009. So I wind up getting 4t equals 122.6165, etc. I think. I assume it goes on. Divide by 4. And t equals 30.65. So to the nearest year, that would be 31 years. That's a long time to wait for. Should go out and do something. Okay, this one's a really interesting problem. It's an example of solving for a different piece of the puzzle. So this is showing exponential growth. It's a house. It's going from 30,000 to 380,000 over 6 years. So we want to find the exponential growth. So we know the t. We want to find the rate. So that means when we set up our formula, we're doing annual growth rate here. So we're going to use our annual formula as a recall. A of t equals the principal. It's growth, so it's 1 plus the rate. And in this case, this is the number I'm looking for here. I want to find the r. And I know the t is going to be 6 in this case. So when I plug all the pieces in, this is 380,000. 300,000. 1 plus r, I don't know what that is, but I know that that's 6. So we're really just solving here for the r. This is a lot like sequences and series we're going to be doing in the future. Excuse me. So this is 1.2666 repeating equals 1 plus r to the 6th power. So raise it to the 1 over 6. Those go away. And I get 1.0401845, I think, equals 1 plus r. Subtract your 1 from both sides, and r is equal to, that's equals 0.04018. So that means, move it over to, it's 4% to the nearest percent. Man, I'm messy. So now I know that the annual percentage rate is 4%. So now I know my formula. So it's A of t. A of t is equal to 300,000. 1 plus the rate to the t power. So I know this, and so this number in here is 1.04 to the t power. We can bring that down if we want. We want to know the monthly percentage rate. So that means, if you recall from the other day, you want to put a 12 on that, but you can't just put a 12 on that. You got to do that. Okay, so then you do 1.04 to the 1 over 12 power, and you get 1.00327. So since this is growth, we subtract 1. And we get 0.00327, move it over 2 decimal places, and to the nearest tenth of a percent is 0.3 monthly percentage rate growth. Okay, same deal here. I think this one says here, growth on yours, that should say decay. There's a little typo there. So we want to figure out the annual decay rate. So it's the same thing as above, but it's just decay. So I just wanted to do 2 of these because we didn't do many of these or any of these in class. But it's still something that you should be able to do with exponents and things like that. It's like a review, but a Common Core fun. So it's decay, so 20,000 is our ending, 30,000 is our starting. It's 1 minus the rate, because this is decay. And then the exponent is 5, because it's been 5 years. So we divide by that 30,000. Whatever. So you get 0.6 repeating. Remember, don't round, don't end it, just let it be. 1 minus r to the 5th. So I want to get rid of that 5, so I raise it to the 1/5 power. So it's 1 minus r equals 0.6, repeating, and that is wrong. I didn't raise it to the power yet, so it is, hold on. Okay, so the answer sheet is slightly wrong. I forgot to raise to the 1/5 power, but it should be 0.92210, blah, blah, blah. We subtract 1, and you remember, so I'll subtract 1, and I get negative 0.07789, etc. equals negative r. We get rid of the negative 0.07789, etc. Move it over 2 decimal places, and you get 7.8%. The annual rate of decay is 7.8%, which, you know, looks good to me. So from this, we have our formula that we can use, the annual percentage formula. And what we want to do now is figure out the quarterly. How much am I going to lose every 3 months from that rate of decay? So we plug this in our calculator. So part B, slightly off. So we do 1 minus 0.078, or it's really just this number right here we could just use. 0.922107, etc. to the t power. That's a great number, and knowing that this 30,000 is here, if you have to find any other values, you can. However, we don't care about this right now. We want to just figure out the new percent or quarterly rate of change. So remember, I want a 4 there. So if I want a 4 there, I have to raise this to the 1/4 power. So when I do that, I get 0.97993 blah, 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 to the 4t. Do 1 minus that number. And I get 0.020069. Move it over 2, and it's 2.0%. So you lose 2.0% every 3 months, and 7.8% for the entire year. So here we have a half-life problem. If you haven't fixed it, this half-life should be 10 minutes, not 5. 5, it's going to take too long. It goes into scientific notation land. So write an equation to estimate the amount of unobtainium left after t minutes. So Mrs. Ittori, over time, we have 1,000 grams that we start with. Remember, the half-life formula is 0.5, and at the top is how many minutes, and the bottom is the actual half-life. So there's my formula. That's all you need. How much will she have left after an hour? So after an hour, remember, half-life is 10 minutes, so an hour is 60 minutes. So that's what we put in for t up here. So remember, the 10 minutes and the 60 minutes, they have to match. You couldn't put 1 hour in there. So 1,000.5 15.5, 60 over 10. Figure out that number, and it's 15.625 grams. How long will it take to the nearest minute to have less than 10 grams of the material? So we do 10 equals 1000.5 to the t over 10. And we solve this. You're solving for an exponent. So you use your x, and you need logs. So you get 0.1 equals 0.5 to the t over 10. So you need your logs on both sides. This part goes in front. I feel like I've done this 600 times. Hopefully you know how to do this by now, and it's second nature to solve for exponents. Or maybe not second nature, but third nature. So it's 6.643 equals t over 10. Multiply both sides by 10. And it's going to be 66.43. So to the nearest minute, it's 66 minutes.